Good afternoon, my name is Corbin Irwin and this is a presentation for CYB610 at Grand Canyon University. Today we'll be challenging our hacking skills and we'll be looking at several different goals and objectives. Our first goal will be to identify the process and reasoning behind penetration testing and why it is a valuable tool for IT security. Secondly, we will enumerate and identify the vulnerabilities within a Metasploitable 2 machine. We will exploit those vulnerabilities to gain root access to that machine. We will then conduct a risk assessment based on those vulnerabilities, and then we will conduct hardening activities on the machine as well. We'll examine the results of those hardening activities by reconducting a scan to kind of identify vulnerabilities and see what the effectiveness of those fixes were. So first, let's talk about the organization of penetration testing. How do we organize a penetration testing activity? First, we need a plan. We need to define the scope of work. Secondly, we need to identify what tools will be used, who will be involved, and the time frame for the testing. Then we will utilize tools to identify possible vulnerabilities within the system, attempt to exploit those vulnerabilities to access the system, its files, or other functions. We will then execute attempts to gain persistence and privilege escalation using those exploited vulnerabilities, and then we will do an analysis. We will organize and prioritize vulnerabilities based on impact and ease of execution. So essentially, we will test the system, attempt to gain access to it, and then we'll use that information to create a prioritized vulnerability schedule. So why do we do this? Why is this important? Well, penetration testing allows for the simulation of an actual cybersecurity event. Events in the US cost companies billions of dollars each year, and the costs are only going up. It's getting more and more expensive. A data breach costs more than it does to conduct regular penetration activities that identify issues before they can be exploited. And penetration testing differs from normal IT activities as it actively attempts to breach security rather than simply looking at building it up. Penetration testing will use the same tool sets as attackers and allows companies to be prepared to defend against them. Penetration testing is an essential part of keeping company data safe, its systems secure, and building customer trust. So what happens when you fail a penetration test? What happens when your procedures or your systems don't work? Well, document and report all the failures once testing has been concluded. Ensure that the points of failures have not been exploited and that the system is secure. So basically make sure that no one has also found these vulnerabilities and utilize them to access your systems. And then suggest fixes to address the point of failure. This could include systematic failure as well as policy failure. So maybe it's the system that failed, or maybe it's simply the policies in place that weren't working. Correct all failures as soon as possible. This stage may include working with stakeholders and other teams to ensure that solutions are effective and efficient. So let's talk a little bit about our Metasploitable 2 machine. Today we're going to be looking at several different tools and how we use them to find vulnerabilities and then exploit those vulnerabilities. We started out our activity today with an nmap scan using the nmap and then the IP address command, and that gave us these results here. We can see on this machine there are a lot of different ports that are open. Some of these are worth looking at because they're very commonly exploited. For example, here we can see that the login port here, the 513, is open. We can see that the VNC, there is a VNC on the system that's open as well. And there's an FTP system and a telnet port. So there's a lot of different ports that typically could be vulnerable. We're going to look at those a little bit more. So next we did an aggressive scan. Here we're able to get more information about the specific ports. Reading through all these ports, one thing of interest is this version of VSFTPD. This is actually an exploitable version. We can look that up when we do some of our further research. And we can see again, Telnet is open. A lot of different information here that we can gain vulnerabilities from. We did an operating system scan here to further understand what we're looking at. The machine is running a Linux kernel, and this is the kernel version here. Got more information on the ports. And then one important thing here, again, it's one hop on the network, so there is no firewall in place before this machine. We then did a services scan to get further information again about those ports. Again, we knew a lot of this. The VNC, we see the open SSH number here, which is actually something worth noting because that's going to be coming into play. The Apache number, Zamba, that could be something we looked at. We saw that in earlier labs. A lot of information about the ports. We then did a NICTO scan. Now this gives us a little bit more information because NICTO is a great tool that allows us to actually get some vulnerabilities that go along with what it sees. So we got a nice list of vulnerabilities that are possible here. We'll look at those a little bit later. And then next we did an OWASP scan targeting our machine. The great thing about doing this scan here is this gives us a much more organized version of what we did earlier. We can see some things that we didn't see earlier, such as the MD5 crypt, possible hash disclosure, path traversal, some anti-click tokens, or sorry, absence of anti-CSRF tokens, and some other possible vulnerabilities here, missing anti-click jacking headers, a lot of different vulnerabilities within the web applications. Next, we did a Nexus scan. A Nexus is great because it really organizes information and makes it very easy to understand what a critical vulnerability might be. And as we can see, there's quite a few different critical vulnerabilities in this machine. From here, we're going to examine some of the different vulnerabilities, and we're going to actually be looking at them in the priority that Nexus uses. So let's move on to that. First, we're going to be accessing the system, though. So how are we going to access the system? There's so many different exploits available on the system, but the one we chose is actually to look at port 513 and that login that we saw earlier, that login service. Now, when we look at port 513 and we look at the login service, it's easily exploitable. We were actually able to install an RSH client, which we did with this command here, sudo apt install rsh-client. You can see that here. Once our client was installed, we were actually able to simply use the rlogin command, logged in as the root user, basically listening for the port here, and then using the IP address. So we just pointed to the IP address, and that immediately gave us root access. So that open port with that service running allowed us to easily get into the system because it was showing the login service. The second part of this, how do we actually gain privilege escalation and persistence? We did this by adding a user using this command here, user add-ou 0 group 0 G0 Erwin, and then the second command, password Erwin. So we use our last name as, or my last name as the username, and we were able to create a new root user. So this puts us in group 0, which is the root permissions group. So when we log in with this username on the actual Metasploitable 2 machine, we can see, yes, we did log in with a new user under the name Erwin, and we do have root access when we use the ID command. So within 4 or 5 commands, we successfully were able to get into the system, gain persistence, and privilege escalation to be root. So let's talk about some of the other different risk assessments that we saw here, or risks and vulnerabilities that we saw with Nexus. That wasn't the only one that's easily vulnerable, and we'll talk about that a little bit more. So we can see here there are quite a few that fall into the critical, medium, high category, or mixed high category and medium category. The first vulnerability is a bind shell backdoor detection. So we can actually see in the port 1524 TCP wild shell, this is another one that's easily exploitable. We were actually able to simply connect with Telnet, the IP address, and then aiming at this port, and that gave us immediate access to root. So this is another one, this port being open and not blocked, easily allowed us to take over that. Second vulnerability within the critical was the VNC server had an easily guessed password, which actually they provided for us with our Nexus scan, which was fantastic. Using our VNC client on our Windows machine, we were able to connect immediately, and as you can see here, we again have root access. So that's 3 different ways we gain root access. Vulnerability 3, this is the one. This is another one on port 5112. This one can easily be used to achieve root access as well. It's a very vulnerable port at 5112. The version of OpenSSH and OpenSSL doesn't use good cryptography, which is what we talked about earlier with our MD5 hash on the previous scan. So all of these keys really should be regenerated, or it should be using a different protocol, because this can cause issues as well. It doesn't actually randomly generate, and they can be guessed. Vulnerability 5 is related to our Apache Tomcat. This is an outdated version. It should be updated to avoid this type of attack, which is a vulnerability found within the APG connector. Basically, an attacker can use it to read application files from the vulnerable server. This is the one we use to actually gain access to the system, which is in the high category. I think maybe it should go to the critical, but we were able to use this to connect. It's actually an easy solution. We'll talk about that a little later. Samba, a similar thing to what we saw in one of our previous labs. Samba should be updated to avoid having vulnerabilities, because this can actually be used and exploited to gain access to the system. Another one that we saw here was the ISC bind service downgrade, reflect DAoS. So basically this is vulnerable to attackers using a denial of service on it because of the slow commands. It's basically a performance downgrade that will cause it to make denial of service attacks much easier. And then the X server detection, we saw this earlier when we were looking at ports, but port 6000 has X11 working. This was actually blocked when we tried to connect to it, so this might not be something that's super vulnerable, and that is why it's in the low category, but it does still show that service and it is running. And then from the medium category, we have TLS service or version 1.0 protocol detected. They have some vulnerabilities due to cryptographic design flaws. Basically, the cryptography there is a little off, and enabling TLS 1.2 or 1.3 and disabling this would be a fix for that. This could be used to guess the keys and get access to the system. So let's do a risk assessment really quick. We talked about some of those vulnerabilities. We didn't go super in depth to them, but we know they exist. Some of them were easily exploitable to get root access. So our risk assessment is that there were several issues identified that leave the system vulnerable to exploitation. We showed that within that assessment that we just did. The analysis showed that some of the security issues were related to policies such as poor passwords, which we saw in the VNC, and mismanaged user permissions. The root user was also active and very easy to get to. Other accounts had root access. We saw that in some of the earlier scans. Many of the components of the system are out of date, which leaves them vulnerable to exploitation. The actual Linux version is no longer supported as well, which is not something we showed. Poor services and port management leaves misconfigured and exposed services that can be exploited to take control of the system. We did this several times. Based on scan information as well as current trends, Nexus rated many of these exploits as critical. They are critical because they easily allow attackers to access the system and steal data, take over the system, and cause damage. Exploits could be used to take control of the system, steal information, or even launch tools to launch or used as a launch pad for other tools and other attacks. So one of the things that we have to consider here too is because this is a web page, people could take over our system and then use our web page to spread viruses to our clients, to other users, to other employees. Another way to gain persistence and spread this attack. So how do we mitigate this? What are our mitigation or countermeasures that we're going to take? What we suggest here, based on what we've seen, is that we should update all software solutions used within the system, such as PHP, Samba, VS FTPD. We should regenerate all the SSH and SSL and OpenVPN keys based on what we saw. Find solutions to migrate the system to a newer version of Linux that actively receives support and security updates. This one's a little more intensive, but if we were using a supported system, it would give us better security support. Ensure that all password policies require more complex passwords that are updated regularly. Basically, let's talk about policy and make sure that these passwords are matching it. If you're using password as your password, that's not good. Reconfigure open ports so they no longer are vulnerable. This is something that we'll talk about in a little bit. Utilize a firewall to filter traffic and secure ports. So using a firewall so that there's something standing in front of this vulnerable server would be much better. Our expected results when we do some of these mitigation counters and countermeasures is current attack vectors will be reduced, vulnerability scans will show fewer results, and the method used to gain root access in this lab specifically, that 513 port, will be blocked. So let's go ahead and instigate some of these changes. The first thing we did was we updated the VNC password. As you can see here, we used this command vnc-ps or passwd and updated the password to something that is more secure, that uses several different digits and symbols, and that made it so that the software couldn't just automatically guess it when they did the scan, and that someone wouldn't be able to access the system very easily. Another way, of course, is to disable the VNC service, but this allows it to stay in place while updating the passwords. We also edited the config file for port 513, which is how we gained access to the system. If we comment out this login command here and disable that service over TCP, it no longer works with the rlogin command or the RSH client. So that was the fix that was suggested by Nexus, and when we do this, we'll see if that actually prevents us from connecting. Another easy fix that we can do and we talked about is the enabling the uncomplicated firewall, which is a specific firewall software. We did this here, and we used the UFW enable command because it was already installed within the Metasploitable 2 framework. And when we enabled that, we did want to make sure that we had some rules set in place. So we set it to actually a whitelist system. So we said default is to deny. So using the command UFW default deny, we denied connections and made it a whitelist rule base, but we did allow connections for the FTTP, and that's how we edited it here. UFW allow FTTP, or HTTP rather. So we scanned with Nexus again once we made those changes to see if we could reduce the actual vulnerabilities. As we can see, the critical vulnerabilities have minimized as well as the high vulnerabilities. So we were effective in blocking some of these attacks. This was done with our VNC fix as well as our login edit. Now, we did this without our firewall enabled just so that we could really see this, because when we do enable our firewall, what we'll find is that the attack vectors are much, much fewer showing up on the scan. Now, when we run our Nexus scan with the firewall enabled, we can see that we've actually eliminated almost all of the critical vulnerabilities that were shown. The only one that's left is the outdated Linux version that really should be updated, and none of the other ones are showing up. And this is because we were successful in blocking all of the ports. We set it to default block ports, access to the ports rather, and we used whitelist methodology, and that was very successful in removing vulnerabilities from showing up on the scans. So what was our reasoning in doing the changes that we did? Well, we selected the changes to address many of the critical vulnerabilities that were shown in the vulnerability scan. We made changes that had no overall cost and were easy and efficient to apply. Some of the changes, such as the whitelist rule for the firewall, may not be long-term solutions, but allow for the system to be secure while long-term solutions are examined. We wanted something that we could do now to protect the system, and something that allowed us to keep it secure while we made and looked into further changes. Some of them were permanent changes, like changing the VNC password and removing the configuration file, or editing the configuration file for the login service. So did the expected results match the actual results? The expected results and the actual results are very close to one another, with the Nexus scan showing a significant reduction in critical vulnerabilities. This matched up with what we thought would happen. Knowing the way that the firewall would work and knowing the other vulnerabilities and how to patch them, we were able to eliminate them, and we were successfully matching our expectations with our actual results. So what did we learn from today's activity? What did this lab teach us? Well, without the results of a vulnerability scan, it would be easy to miss vulnerabilities like the one we saw on port 513. This misconfigured port could have went unnoticed until someone exploited it. Because if it's a service that you're using and you just don't understand how to configure it properly, it's very easy to miss something like that. But the vulnerability scan showed it right away and showed us how to fix it. Not all the systems can be updated to patch vulnerabilities, so other mitigation tactics may be needed and implemented. So you can't always just update, patch, and fix things that way. You need to look at the other problems that you can fix to mitigate risk from maybe someone finding a vulnerability and exploiting it. How can you mitigate the risk of them either getting privilege escalation or persistence? You've got to look at all of the different avenues for blocking attackers, not always being able to update things. Effective cybersecurity efforts require penetration testing to be part of the program design. So if you're designing a cybersecurity program, an IT security program, and you're looking at it without penetration testing, you're missing a huge portion. You either need to be doing it in-house or you need to have an outside group doing it for you, because it is important to understand how those systems work, how attackers are going to look into your system, and then to be effective in blocking those attacks so you're not vulnerable or liable. These are the references that we used in our discussion today. I hope you all had a wonderful time and learned something. Have a great night.